Welcome to EDU World Space.
We're going to prove that the moment of F1 about F2 is equal to the moment of F2 about F1. And we're assuming that the magnitudes of both force vectors are equal. So to start with, I'm going to write out the equation for the F1 vector. So that's going to be equal to the magnitude of the force vector times the unit vector of force 1. And the equation for the force 2 vector is going to be equal to the magnitude of the force vector times the unit vector of F2. And I'm now going to write out the equations for the moments of both vectors. So for the moment of F1 is going to be equal to the unit vector of F2 dot r vector cross F1 vector. And what we can do is we can take this expression here and we can plug it into this term. So that's going to look like the unit vector of F2 dot r vector cross magnitude of F times the unit vector of F1. And we can take this term out of the cross product and rewrite this as the unit vector of F2 times the magnitude of F dot r vector cross the unit vector of F1. And next I'm going to write out the moment for the F2 vector. So the moment of F2, this is going to be equal to the unit vector of F1 dot the negative r vector cross F2 vector. And we can take this term and plug it in to this term. So then that's going to be equal to the unit vector of F1 dot negative r vector cross magnitude of F times the unit vector of F2. And we can also, so we can take this magnitude out of the expression and we can rewrite our scalar cross product. And after rewriting it, we end up with magnitude of F times the unit vector of F2 dot r vector cross the unit vector of F1. And we can now see that these two terms are equal, with the top term being m of F1 and the bottom term being f of F2. So we can now conclude that the moment of F1 is equal to the moment of F2.